Hi, thanks for joining me. Today I've got a fun little geometry problem. We have a diagram here which is a big square with side length 2, and inside this square we've got two different semicircles. And both of these semicircles have the same center at this point here, and this center also happens to lie on this diagonal of the square. So the side length is 2, and we've got two semicircles with a nice line of symmetry here. We want to know what is the total shaded area, so this semicircles area plus this other semicircles area. If you want to have a go at this problem, pause the video now and give it a go for yourself, and I'm going to dive straight into a solution. Okay, so what we're going to do to solve this problem is to call the radius of this smaller semicircle, let's call it maybe r, and like mathematicians would, we'd call this one big R. So we've got little r and big R, the radii of these two circles, and obviously perhaps we want to work out what the little r and the big R are, and once we know what they are, we can then work out the areas of each of these semicircles. Okay, so can we perhaps get some equations involving r and r? Well, yes, we can. If we look at this kind of part of our diagram here, that's of length little r. And if we extend that straight line down here, that's of length big R. So we get one equation straight away that little r plus big R must be equal to 2. Okay, so ideally what we want to do now is find another equation involving little r and big R, and then we'll have two equations which perhaps we can solve simultaneously to work out what little r and big R are, and then we can get the area of these. So in fact, if you want to, see if you can spot how we can get this other equation. Okay, so the way we get this other equation is actually, well, it's not particularly obvious, but what we want to do is firstly look at this triangle over here. So it's a right angled triangle, and just by the symmetry of this picture, it's also an isosceles triangle. And so I can do some stuff with Pythagoras' theorem here. If I call the side length of this triangle little x for now, I can say that x squared plus x squared equals this hypotenuse squared, and you can see that the hypotenuse is 2 times big R. So that equals 2r squared. And so if I simplify this, I get x squared equals 2r squared. And so in other words, x just equals root 2 times r. So I get that one of these side lengths of this isosceles triangle is root 2 times capital R. And what we're going to do now is use that and look at this triangle here. So this one here. And again, we realize that this is a right angled triangle. This is no longer an isosceles triangle, but it is still right angled, so we can still use Pythagoras' theorem. This guy is now our hypotenuse, which we've just worked out the side length for. So we can have that as our c squared. And what are the two other side lengths? Well, this side length here is just capital R. And how about this side length? Well, if we think about it, this is just, let me change color to make this a bit clearer. If we look at this square here, this is just the diagonal of that square. And this square has side length little r, so that diagonal must be root 2r. Again, just from Pythagoras' theorem. So we get this as our equation. And now if we just expand and simplify this, we get r squared equals 2 times little r squared. And then just dividing, square rooting both sides, apologies. This is r equals square root 2 little r. And so now we've got some equations here, this one and this one, so we want to solve them simultaneously. So I can just say r plus root 2r equals 2, factoring out the r gives me this, and so r equals 2 divided by 1 plus root 2, and if you just multiply top and bottom by root 2 minus 1, you get this is 2 root 2 minus 2. So r is equal to 2 root 2 minus 2, so little r that is. And so now I need to work out big R, so I just need to multiply by root 2. So r is equal to 2 root 2 times 2 is 4 minus 2 root 2. And so now all I need to do is work out the area of this, and I just need to use the fact that the area of a circle is pi r squared. So the area of this will be pi times little r squared. So maybe we should work out what that is. So r squared is just 2 root 2 minus 2 squared, and if we just do this the old-fashioned way of expanding the brackets, 2 root 2 times 2 root 2 is going to be 8. 2 root 2 times minus 2 is minus 4 root 2, but we're going to get two lots of that. So minus 8 root 2, and then we're going to get plus 4. And that's going to be just 12 minus 8 root 2. And capital R squared is going to be 4 minus 2 root 2 squared, which is going to be 16 minus 16 root 2 plus 8. So that's going to be 24 minus 16 root 2. And so I'll just bring this back up here. So what's the total area? It's going to be pi r squared plus pi capital R squared over 2, which is going to be pi over 2 times r squared plus r squared. So 12 plus 24 is going to give me 36. And minus 8 root 2 minus 16 root 2 is going to be minus 24 root 2. And so simplifying this is pi 18 minus 12 root 2. And so the total shaded area here is pi times 18 minus 2 root 2. Thank you for watching. I hope you have enjoyed this nice little geometry problem. These ones normally just involve some secret Pythagoras' theorem, so it's just about finding the right triangles. Anyway, I hope you have enjoyed this video. Thank you for watching. I'll catch you in the next one. Have a great day.